Hello students, and welcome to revision of the chapter Binomial Theorem. According to Binomial Theorem students, we have seen a basic expansion of a plus b bracket raised to n. So we'll start from that expansion, that is a plus b whole raised to n is nc0 a power n b power 0, right, plus nc1 a power n minus 1 b power 1 plus nc2 a power n minus 2 b square plus, again we continue in this way, and the last term will be ncn a power 0 b power n. Alright, now we have studied this binomial theorem in details with different pointers. So we mention here different notes. The first one, in above expansion of a plus b whole raised to n, nc0, nc1, nc2, all these numbers up to ncn are called as binomial coefficients. Okay students, so all these numbers are called as binomial coefficients. Now in expansion of a plus b bracket raised to n, the major challenge is to find binomial coefficients. So these coefficients are obtained by a formula that we learned before, that is NCR. N combination R is n factorial divided by n minus r factorial into r factorial. Now students, we can use this formula to calculate all binomial coefficients. Now we have one alternate also, and this is simpler or difficult. Let us see. This alternate is called as Pascal's triangle. So we are focusing on to calculation of binomial coefficients, and we say there is a formula, that is n combination R or Pascal's triangle. In Pascal's triangle we start with 1 and 1. Then we copy the 1 here, and 1 plus 1 from the above row is 2 and 1. The third row starts in a similar way, that is 1, then above row referring 1 plus 2 is 3, 2 plus 1 is 3, and again 1. Now again referring above row, we can write the next one as 1, 4, 6, 4, 1. And similarly, the fifth row will be 1, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 5 and 1. Okay, so you can go on calculating these numbers just by adding numbers in the previous row and copying 1, 1 in the end. Alright students, now interestingly, the first row represents 1 CR, the second 2 CR. That means if I want coefficients of 5 CR, I can refer the last row. So this Pascal's triangle can be said definitely an easier way to calculate binomial coefficients, that is NCR. Now students, let us see one example. How do we calculate these binomial coefficients very fast using Pascal's triangle? For example, let us say we need 5C2 to be calculated, and we can directly say the last row is 5C0, 5C1, 5C2, which means value of 5C2 is 10. Alright. Now once we understand how to calculate binomial coefficients, let us study the binomial theorem further. Now we learn number of terms. Number of terms in the expansion a plus b whole raised to n is n plus 1. Alright students, so whatever is the bracket power n, we add 1, and those many number of terms will be present in the expansion. Alright, let us study further. In pointer 3, now we are going to find out any random term in the expansion, that is called as general term in the expansion of a plus b raised to n. So we write here general term in a plus b whole power n. So students, general term represents any random term, and I can use this formula to find out any random term directly from a plus b bracket raised to n. And this formula is a plus b bracket raised to n general term is given by tr plus 1 equals to ncr a raised to n minus r and b power r. So this expression gives me the general term, which is very important and needs to be remembered. Okay, students. Now here we can put different values of r to get different terms. Let us go ahead. In fourth pointer, we say in the expansion a plus b whole power n, kth term from end. Now students, there are some questions which will ask you to find out kth term from end, and we say kth term from end is n minus k plus 2th term from start. So kth term from end can be referred as n minus k plus 2th term from start, which can be given by t n minus k plus 2. So we can calculate t n minus k plus 2 using general term formula. Alright, let us proceed. In pointer number 5, students, we are going to learn some very important pointers for your problems, that is middle term. Now students, if you expand a plus b bracket power n, there are going to be n plus 1 terms, as we know. Now the middle term can be obtained directly if you focus on values of n. So the power n can be even or odd. Based on these categories, we get middle term as if n is even, if value of n is even, then we say the middle term is given by t n by 2 plus 1. So we write here, then middle term is t n upon 2 plus 1. So if you put value of n, you get the particular middle term for a given expansion. Similarly, if n is odd, then the middle terms are 2, that is there are two middle terms. Okay, students, so if n is odd, that is power is odd, we say there are two middle terms, and these are given by t n plus 1 by 2 and t n plus 3 by 2. Okay, so you just substitute values of n here and we get middle term. Let us proceed for next important pointer for problem solving, that is pointer 6. Now we are going to think of greatest binomial coefficients. So students, in expansion a plus b whole power n, let us think where the greatest binomial coefficient occurs. Now greatest binomial coefficient means greatest value of binomial coefficient, that is NCR. Alright students, so here we are going to learn how to calculate greatest value of NCR for a given value of n. Now if n is having even value, then n by 2 gives the greatest value. So for a given n which is even, we say greatest is nc n by 2. If value of n is odd, students, then the greatest coefficients are nc n minus 1 by 2 and nc n plus 1 by 2. Okay students, so when n is odd, there are two middle terms and there are two greatest binomial coefficients. Now, are these two pointers 5 and 6 related? I will say yes. See here, students. The star statement says, in any binomial expansion, so if you expand any of the binomial brackets, then in any binomial expansion, a plus b whole power n, we can observe that always middle term has greatest binomial coefficient. That is, when you calculate the middle term, you get the greatest binomial coefficient. Alright students, let us study binomial theorem further. Now, seventh pointer says, here we are going to see a method, students, to calculate one particular type of problem. This is method to find coefficient of x raised to k in, let us say, an expansion x plus y bracket raised to n. So if we have expansion x plus y bracket raised to n, how to find coefficient of x raised to any power, let us say k. There are steps that we follow. The first step A is find general term t r plus 1. Now step B says in general term, that is t r plus 1, equate powers of x. So equate power of x to a value mentioned in the question, that is k. So when we equate power of x to k, students, in general term, we get value of r, that is required value of r. Now students, from value of r, how to find the coefficient of x raised to k? That is step 3. Substitute value of r in general term, that is t r plus 1, to get required coefficient of x raised to k. Okay, so by following these 3 steps, we can find coefficient of any term or any power of x. Now students, here is a particular type of question which normally appears, that is, in a given binomial expansion, how to find independent term. So in a given expansion x plus y bracket raised to n, we can also find a term independent of x. So when a term is independent of x, students, let us see how to find. So in a given expansion x plus y bracket raised to n, we can also find a term independent of x. For this purpose, equate power of x to 0. That is in step B above. So to find independent term, we follow above 3 steps only, but in the middle step, that is step B, we equate power of x to 0. Now students, term independent of x is also referred sometimes as constant term. So term independent of x is also called as a constant term because it does not contain x. Alright. So here we discussed one particular type of question. Let us proceed. Now, eighth pointer says, now students, we have seen how to find greatest binomial coefficient, but there is some relation between them also. Let us study that. Relation between binomial coefficients. That is relation between NC0, NC1, NC2, so on up to NCn. So now first pointer here says NC0 plus N combination 1 plus NC2 plus NC3 and so on up to NCn. Sum of all these coefficients is always 2 raised to n. Okay. Now the second pointer is again interesting. NC0 plus NC2 plus NC4 plus dot dot dot, that is even values of r sum is equal to odd values of r sum, which is 2 raised to n minus 1. Alright students, so even binomial coefficients sum is equal to odd coefficients, which is 2 raised to n minus 1. Now the ninth pointer says binomial theorem for any index. Now students, after learning all these pointers, now we expand our horizon and say we can have binomial theorem for any index, that is any value of n. In a plus b bracket power n, if value of n is negative, let us say value of n is minus 2, or a fraction, let us say half, then what we do? Then we follow another type of expansion, that is a plus b whole power n is equal to. Remember, this has to be used when n is negative or fraction. So we say a plus b whole power n is equal to a raised to n b power 0 plus nc1, that is we write value directly n into a raised to n minus 1 b power 1 plus n into n minus 1 upon 2 factorial a raised to n minus 2 b power 2 plus n into n minus 1 into n minus 2 upon 3 factorial into a raised to n minus 3 b power 3 and so on. Alright students, so here we learn the binomial theorem for negative or fractional values of n. Now before we apply this kind of expansion for a problem, we have to take some precautions to get a finite answer. Okay, students. So before applying above formula, we ensure that is in any problem, we'll make sure that value of the first term, that is bracket, contains a first. So value of a should be 1 always. So before applying this formula, students, always value of a should be 1 and value of mod of b should be less than 1. So here we complete the revision. Thank you.